Sup guys, welcome back. Let's see if we can figure out why this is happening. That we get the wrong stuff into our array. So let's add some debug messages inside of this function right here. So let's see, it is very dense, but we could do something like this to make it a little bit easier for ourselves to understand. So this can be put here. So this line right here, this is what happens at each iteration, basically. But before we go there, I want to see that the intermediate array, this R, that it contains the correct things. And I will do it quite simply by just, let's see, I guess we could print it like this. Let's do one per line. And instead of creating another loop, I will just do it inside of this. Okay, so what do we want to print? We want to know R at an index position. And R is a void pointer, so I think we'll just do like this. 1, 2, 3, 4, 5. And it's not necessarily going to have these many, but I don't think it'll crash. Even so. Let's also print the argc. So let's see. At this point we have not increased argc, so it should contain the number of arguments, I think. So not +1, as it will later on. And this is argc. Maybe we should do a little space here, just to separate the two things. And let's exit afterwards so we don't mess with anything else. Alright, this should make us a little bit wiser, I think. So this is how it looks now. This is how the end structure looks. We are going to look at the intermediate structure first. Okay. What line? 67. this one. Oh. Okay, we need to cast this thing. Alright, let's see what we got. Okay, so we have, what are we sending to it first of all? 253 210. The 2 is okay, but not the rest. So we do args p, which gives us the first argument. And then, we did the same error once again, didn't we? We plus the arg. No, wait a second. No, we minus the p. It's equal to p. And how did we do it up here? We did args p, set val to p. We dereference it here, which we can't really do here. But shouldn't we get the address in that case? This does not look like addresses to me. Besides, this is the correct value. What if we were to do this? But then we would get stack addresses, wouldn't we? Yes. Is that what we want? Well, we don't want to have these stack addresses, which are local to this function. But is that what we get? So basically what we're interested in is the addresses of these, right? Let's print them too. Let's just print them on one line like this. There's only 3 of them. And what do we have? We need to cast them, and we have XP. We have YP. We have ZP. Oh wait, they are uninitialized here. That is correct. Right. Okay, so we get those. But XP is equal to X. Alright, so it's equal to the values. But inside of these void pointers, don't we want the addresses to these things? Or do we want to put actual values there? Because we have no real way of differentiating between. But does it really matter actually? Cannot the assembly function handle figuring that part out? So basically what we do want to have in this case is this, I guess. So we send them as pointers. And what else did we change? This thing. And I wonder if this is the right way, by the way, because we can't really check afterwards. So what we're really interested in is while p plus 1. And then we could decrease it here, perhaps. But it wouldn't make much difference, would it? First it's p, and it reads the p, then it decreases it, and this checks if the new p is 0. Maybe it's correct either way. Okay, so now it crashed. So we got this stack addresses, but it crashes up here. Maybe we should leave that alone. Or maybe this. No. Okay, that's not it. What else did we change? We don't even get down here. So does it crash this time because we sent stack addresses? Yes, it does. 2 and 1. And the input is this. And if we were to go the other direction, we crash. But it shouldn't crash. We are only looking at addresses, aren't we? Let's see what GDB says, so we know where and why it crashes. We try to move into a memory address from EDX, the value of EX. And what is EX? 232. Which was it? EDX? Yeah. EDX is 0. So we try to move something into a 0. Maybe we can see for things around here if we can figure out where we're at in the function. So we test something and we compare something to 0. Something off of the stack. And are we in a loop? Let's put in an exit here and see if it crashes still. It does. So it's below here. What about here? Okay, it might be the print F then. But if that is the case, why doesn't it print the number of arguments? Is it updating correctly? Yes, it is. Oh, wait a second. Am I going the wrong direction? Yeah, I am. I should move the exit upwards, shouldn't I? Think I'm getting tired. Okay, so it seems like it crashes here. And why does it do that? Because the only thing we are doing is we're filling out this R thing. With the current value of P. And we aren't really dereferencing anything because P is just a pointer. And we plus this pointer. And we set it to its current value. Maybe we could print some dot or something at each iteration. Oh, that's a lot of dots, isn't it? Okay. We should only loop 3 times is the general idea, and we do have our 0 here. Well, we are going in the wrong direction now. So, but it still was problems with this. Because we don't get the right values or the addresses, or do we? Do get some stack things here. Maybe it has been pretty much working all along. What if we were to change these to the addresses of these integers? 0C 8. It's not these addresses. What about the addresses of these pointers? Nope. It's not them either. So are we talking about the local? Yes. We are talking about the local stack of this make args function. We need to dereference in order to get any useful information. But how do we dereference void pointers? That's not really something you do. Can we just treat them as 32-bit values? Because that is always what we are going to use. Or is it better to send well, I guess we could treat them as integers. So we want to dereference this as an integer. Can we do just that? we need to at least make this an int pointer first. And then we can take this as an integer. Maybe this is what we want actually. But now it crashes because of this weird 2 that we got. Well, I guess we need to... Do we need to change this to... Maybe we just need to change the type of this P and treat it as an int star all along. But it's still... Maybe instead of just putting a dot like this, we can print the current value of P. So P is equal to 2. Well, where does this 2 come from? Doubt it's the same 2 as here, right? Oh, it is. Which means we should not dereference anything. This is what we want to do. And we can keep this as a void. Uh, 987. It's this code that is wrong, I think. Because what we get is here we dereference and get the value, and then we can't possibly find the other one. Yeah, well, we should be able to do that. No, we can't. So what we want to do is this instead. And now we should get the real addresses, right? Oh, that's a lot. But it's still increasing them by 1. Did I change something else without noticing? Right, now we're back at this. Okay, so these are the stack addresses. And the stack addresses gets put into P. And we have to dereference the stack addresses to get to the real thing. Which means we need to do this. And no, yes, we need to print it as an I. But down here, this needs to be void. And then we need to dereference the int star of P, I guess. Mm-hmm. 920. Okay, so the thing that's printed here are the stack addresses. So that's not very interesting. We want to print the dereferenced version of that. So this should be an integer. But we still need to dereference this as an int star. Huh? Well, now we actually do get some stuff. And we get the 9. That's the first argument. Maybe it's easier if we do this. And we change this to an integer. Okay. Now we're actually starting to get some interesting stuff here. We had a 9. What else should we have? 953. We get a 5, but is that the real 5? And do we do minus this thing? But with the current code, shouldn't we plus it? Nine, 5, 3. What do you say about that, huh? But we do not get the 0. Yes, we do. But we need to compare the dereferenced 0 as well. Okay, we're starting to get there. Alright. So the problem was probably that the void pointer maybe just jumps one step when you increase it, even though it is actually 32-bit. Never mind, let's see. This should be star pp. Okay. So we get the 3 arguments. Well, it says 4 here, but never mind. No, not never mind. Shouldn't it be 3 at this point? Because otherwise the other thing will be wrong too, huh? Because we are looping 1, 2, 3, 4. And how many times? Yeah, we increase it once more. So that's one problem. So I think we actually should decrease argc here. Alright, so 3 arguments, and then we print all 5, and these 2 are zeroed. That's perfectly fine. They are in the right order according to the argument list. And when we copy it to the intermediate structure, let's remove this exit and we should be wiser. Okay, that looks weird. argc is correct though. This looks weird. What do we do here? We set p equal to the array at the index argc. So that is at the index 4 to begin with. The index 4. That is too much. No, it's the index 3. We increase this afterwards. Alright, so at the index 3, that's what p is pointing towards. And then we change the argv of the new structure at index 3 to p. I wonder if we should do this though. No. Maybe we don't have to be so flashy. Let's create a simple loop. where we do for n is equal to 0 as long as n is less than argc. Which means less than 3. N plus plus. And we simply, let's see, we take our a argv at n position and we set it to the void star of no, we don't even need to cast it. We set it to the R, the intermediate structure at the same index. And maybe we should zero out the intermediate structure. Just to be sure. We did create our nifty zero function, so why not use it? And this takes byte by byte, and we want to pass it the R. Or rather the R like this. And what do we want to put there? We want to put let's see, size of void star times 5. That's what. Alright. Simple enough. argc is 1 now. Do we override something with this, or is the problem with the loop? It's not here. We never assign it because we did that in the loop. Okay, makes sense. It does make sense. Now I believe it should work. And it does work. Yay! Yay! Let's remove some of these ugly messages. Let's clean this up. What exactly do we want to print? Well, we want to print what we're doing right now. So this is the final thing. Now we can create one of those argument structures, which is great. Now there's not much left actually. Let's see. The only thing left is calling this function that we are interested in. And I think we can probably do that by macros. So let's see. We need to define a function, or a macro rather, which is an asm call. And what will it take? It will take the name of the function that we want to call. Let's call it f, and we need to have some args. And we basically need to do two things. We need to create one of these argument structures by passing the arguments to make args. And then we want to, I think we want to put this inside of a do block. So we get a local scope and we can create a function pointer. But will GCC accept a generic function pointer taking a variadic number of arguments? It used to, but I'm not sure it will still. But, well, let's try. So let's define a function pointer to begin with. And it's always going to return a 32-bit value. So let's say we have an int 32. Let's call this function fn, or fp for function point, or just p. And maybe we should have an underscore just to safeguard against collisions. And if we just leave this empty, that would, before it meant that we could use any number of arguments. I'm not sure if that's true in the latest GCC versions, but we'll see. And let's also create one of these args structures. So args, no, we cannot call this args, that will collide. Let's just call this A then. So we'll create one of these args structures. Let's just say these are the arguments, or we can possibly do this. And args is equal to make args, and we send the A. Maybe we need to have some kind of check as well. So if it returns 0 at least. So if we don't have an args, well, what should happen then? Well, we need an output variable as well. So maybe just call these input and output. No. Output and input. So if we don't have an args, we will set our output to 0. Otherwise, we will set our output to first we need to set this function pointer. So that should point to the address of the function. So now we can just set our output variable to a call to this function pointer, providing the args structure. And then we just do the while false trick, so we don't run this more than once. Maybe we should do double parentheses here in case we want to send an expression. And we can't really do it with this, since these are several parameters. I think this should work, right? Hope it does, because it's always messy to troubleshoot these macros. And I wonder if we should have a regular function calling this asm call instead. So we can export it, and so that we can return something. Don't have to rely on these output variables alone. So let's say we have an int32, or maybe void star asm call, and here we do only, but we will have to deal with the variadic stuff again, wouldn't we? Let's not. It's too messy to do that outside of macros, and we've done it already twice. So okay, so how do we test this? Well, we have this encrypt function. So let's do int32, and this will be our output. And the only thing we need to do is like output is equal to asm call. Did I change it back to no? Asm call, and first we need the name of the function, and or the subroutine, since this is an assembly function, and that was called encrypt. And we need to have a output variable, which we do, and a couple of arguments. And if I remember correctly, this function used 2 arguments, and the result is just those added together. So let's say 3 and 6. And then we print the result. And we also need to import this encrypt thing. So let's do that. And in C we import using the extern keyword. So we're going to have an external function called encrypt, and it's going to return an int32 in our world, and 2 arguments, int32 in int32. All right. Oh, that was not what I was hoping for. Data definition has no type or storage class. args is equal to make args. And we define it right here. That's weird. Did you mean args with a big A? What is args with a big A? Oh, that's this one. No, I meant this one. Ah, I forgot one of these. Weird error message for that kind of error, I think. Okay, that's better. Expected expression before do. That's right. Because output, we don't do it like this. We just call asm call. And the output is one of the parameters. So now, ladies and gentlemen, I believe it will compile. No? Assignments, from incompatible pointer type inter. Okay, so it bashes me because of the arguments, as I feared. Maybe we could do something like type in 32 in 32. I wonder if it's possible to do something like this. So what I want to do is something like define type, and it takes an x, and it should in turn define asm call type to whatever inside of this x. I'm not sure this is gonna work. Because what I want to do is I want to put it here as call type. But can you really define something inside of a macro? Well, I guess we'll see. No. I think it's bad that we can't, that this is not possible. Well, maybe we can do it slightly better in at a later point. For now, though, let's just do this. Parameter names without types in function declaration. Because the macro gets expanded first, and then we define it. So basically well, let's fix that at a later point. For now, let's just put it here and be done with it. This is not what I want to spend my time troubleshooting. Define type in 32 in 32. Then we include this H file. And right, we didn't use that. Okay, but then it may actually work to do it my way. I hope I at least can put it here. And let's change this to type. Passing in argument 1 of p makes... right, I didn't think about that. We always send the args structure. So this problem is not really a problem. We can remove this thing. And we can just do args star here. And that will always work. Nice. Or what is it? Right, we need to do that when we do this as well. So maybe we should have a macro for importing stuff. So the user won't have to deal with these argument structures and whatnot. So let's define an import alias or macro which takes an x, and what it does, it runs extern x or x. Or maybe just x. Extern x, and then we need the int32 and the args star. So now we just do import what it's called, encrypt. Like so. And it compiled. Alright. Moment of truth. If this does not work now, that means the assembly is wrong. And there probably is some errors with the assembly, but because we haven't really been able to test this without this C code. But we're at least done with the C code, so let's see what happens. We do actually get an output and no crash. It's the wrong output, perhaps, but at least something. So, we are getting there. We are. And maybe we can export another variable, function. Let's say, just to see that it actually runs it and stuff. So let's say we have a global myExit. And let's copy this encrypt and call this myExit. thing it's going to do is it's going to move into EX01, move into EBX, let's say let's say 9, and then call it the exit system call. So it should exit everything, and we should get a return value. Right? And we need to import it as well. And we need to call it. So asm call, and this is going to be my exit and no arguments. Oh, I forgot the output variable. We still need an output variable, even though we're not interested in the output. Undefined reference to my exit. Didn't we export it? So when we run this, nothing should seem to happen. Oh, it's seg false. Maybe that's because we haven't handled the case with 0 arguments. So let's just send a dummy argument. Okay. So let's remember to fix that 0 argument case as well. But for now, let's check if we get a 9 as a result. We get a 9. Alright, so now we can successfully call our own assembly functions. And we can send arguments. Only thing left is to fix the assembly code so that we can get back a real return value as well. Not bad for one day, huh? So let's break there. If you like this episode and you would like to see the next episode in this series, please hit the bell button and the subscribe button. And if you like this episode, please like. Thanks for watching. Thanks for today.